a tree grow? Why does the wind blow? When does a flower bloom? How can a rocket shoot to the stars or land up on the moon? It's science and technology, engineering, mathematics. Get smart, keep it simple. Let's learn about STEM. Hello friends! Today we're going to talk about states of matter and phase changes.
What's matter?
I'm like a little tired, but I'm fine.
What is matter?
No. Matter is something that has a volume and a mass. So it takes up space and can be weighed. So we're going to talk about the phase changes that matter can undergo when you change temperature and pressure, or one or the other, or a combination of both. Matter can be in 3 main phases. There's 4 that are naturally occurring. One of those is plasma. We're not going to get into that right now, but the 3 main ones that you're going to see all around you all the time are solid, liquid, and gas. Water is the most readily available in all 3 of these phases. You can see solid water as ice, liquid water, you drink that. It's in ponds, it's in lakes, it's in rivers, it's all around you. And then the gaseous form of water is known as water vapor. So water vapor is steam. You can see this a lot of times if you live near factories or plants that are exhausting their steam. You can see that rising into the air and then filling the space around it. So we need to define what is a solid, what is a liquid, and what is a gas. So solids are going to have a regular and repeating pattern of molecules. So everything around us is created with molecules. In the solid form of water, you've got these molecules that regularly repeat in a nice organized pattern. So they're stacked up real neat, and they're all straight, and they're all organized, and they're all nice. But then if you melt that solid and it becomes a liquid, your molecules are still pretty chill, not a whole lot of energy, but they're moving around. The solid maintains its shape and its volume. The liquid, it's going to maintain the volume, but its shape is going to be a little bit jiggly. It's not going to be rigid and very structured. It's going to be moving around pretty freely. Your gas, when you add more energy, so let's say you bring that temperature up some more, your gas, it's just doing whatever it wants to. It's very energetic, it's flowing freely. It does not have a defined volume. It does not have a defined shape. So you've got a solid is going to stay the same shape. It's going to stay the same volume. Your liquid can stay the same volume, but you can swirl it around and jiggle it, and it's not going to stay in the same shape. Gas is going to fill its container. It's going to flow freely. It has no defined volume. It has no defined shape. It is just living its life. Gas is harder to explain, and it's harder to grasp that concept because you can't always see it very well. In our demonstration, we'll look at water vapor, which is the gas form of water, and you can see it swirling around, and then it almost disappears, but it's just spreading out so much and it's filling the air around it that you can no longer see it very well. A phase change is something that can be undone, or you can go back and forth between the different phase changes. Those phase changes, they can be, I don't want to say undone because nothing's permanently ever being done. You can transition from different state of matter back to another state of matter, and you're not changing the chemical composition of that matter. In our demonstration, you will see that some things, when you add heat to them, they're not going to maintain their chemical composition. They are going to burn away into smoke, which is, it does not have the same properties as it originally did. So that is not a phase change. You can't grab that smoke and squish it back together or decrease its temperature and bring back a piece of paper. It's a chemical reaction. It is not a phase change. The phase change from solid to liquid is called melting. Going from a liquid to a gas is called vaporization. Going from a gas to a solid is deposition. And then going back around from a solid to a gas is sublimation. From a gas to a liquid is condensation. And from liquid to solid is called freezing. I think that we should go into the kitchen and do some demonstrations so that you can more easily see and more easily understand what is phase change. We're going to look at some demonstrations of things existing in solid, liquid, and gas form. We're going to look at water and how in our everyday lives it can very easily exist in all three of these states. By increasing the temperature of ice, we will see it melt into liquid water, and then continuing to bring that to a boil, it will vaporize and go from liquid to gas. We're also going to look at just a few things. We're going to add heat via flame, and we will see how they're not going to melt and they're not going to vaporize. They're just going to burn away. So they're actually breaking down their composition. Their molecular structure is changing. It's not water or H2O melting to be, so water as H2O frozen is ice, and then the liquid H2O is water, and then gaseous H2O is water vapor. These things actually break down into their different, they break down into different compounds. They're not going to burn into liquid paper and then gaseous paper. They're going to break down and decompose, and then they will be smoke, which is different than a gas form of a compound or of an element. So this is just some engineering paper. This is a solid. It has a defined volume and a defined structure. But when we add fire, you see how it's not melting. There's no liquid dripping away. You're not seeing paper or vapor, which rhymes. You can see some ash. I don't know if you can see that. I don't know if y'all can see the ash falling. There's some ash here. So that's just burnt up paper. It's not in a different form. It did not go through a phase change. It's just breaking down. And so you can see the smoke now. And again, that's not like a gaseous form of paper. That's what is creating the paper, breaking apart and breaking down and releasing into the atmosphere as smoke, not a gas. That is really smoking a lot more than I thought it would. Water does exist in the three main states of matter, or phases of matter. So even the melting point for ice is pretty low. Water freezes at 32 degrees Fahrenheit, so I'm running about 98, and I can very easily melt this with my hands. So you can see that this isn't burning away, it's not decomposing. This is frozen, solid H2O, more commonly known as water. And then when we add heat, you can see it's dripping. So that's now your liquid H2O, or your liquid water, which is how we mostly see it. I'm going to get set up. I'm going to actually add some ice to this pot. We are going to set it on our stove and let it heat up. And we're actually going to watch it go from solid to liquid and then to gas. So we can see this ice transform and show us all three of the most common phases of matter. So we've got our ice in our pot. We are going to put it on the stove. We're going to add some heat. It's going to go from solid, it's going to melt into liquid, and it's going to vaporize into a gas. And we can see all three of our main phases just in our home by heating up some ice. As the solid water heats up, it melts into a liquid form, but before it evaporates away from the surface of the water, you can see the liquid turning into its gaseous form and creating bubbles within the water itself. Then it gains enough energy and it breaks that surface of the water and it releases as steam above the water level. As we added heat, we added energy to those states of matter. So your ice, as it built up more energy and those molecules started moving around more, it liquefied, it melted and turned into that liquid. And then the same for your liquid, the more heat was added to that, it got more excited, it was energized even more, it spread out even more, and it vaporized, it released into its gas form. For some matter, you can just add heat and see all three of these phase changes. With other matter and other substances, sometimes you'll have to increase the pressure to go from liquid to a solid. Sometimes just cooling it down in its liquid form, it's not going to reach its solid form. You have to pressurize it, you have to squeeze on it really hard and push those molecules together, because just decreasing the temperature is not enough to take all that energy out of those molecules and squeeze them and compact them to put them in solid form. But to our advantage with water, we can very easily just heat it up and see all three of our main states of matter: solid, liquid, and gas. Thanks so much for tuning in and learning about phase change and states of matter. Bye! Thanks so much for watching. Here are some more videos you might like, and please subscribe so you can keep up to date and watch new videos as they're released.